Hello, my name is Tyler LaBelle. This is my Doane Chemistry 2 Interactive Advanced Concept Presentation 2. For this presentation, we're actually going to do a really cool clock reaction. Now, for this experiment, you're going to need a couple of things. The first that we're going to need is iodine tincture, vitamin C, cornstarch, and distilled water. Now, for this experiment, it's actually important that you use distilled water rather than regular tap water, because regular tap water, depending on where you are, can contain different chemicals such as chlorine, fluoride, fluorine, uh, iron, potassium possibly. And right now here in Florida, we're going to experience a hurricane here real shortly. So there's going to be all kinds of stuff in the water that you don't want getting mixed in for this chemical reaction. Now, to start, we're going to actually have to create two solutions. And I already started this for time's sake, so you can see what we're going to do. So in solution A, what we're going to do is we want 2,000 milligrams of vitamin C total. Now, depending on the milligram tablet that you get, you're going to have to add more or less. But I have 500 milligram tablets, so I had 4 of them. And then what I did to crush them up is I actually put them in a plastic bag and I just flattened them into a powder with a spatula. And then I opened the bag and put it in this cup with 60 milliliters of the distilled water. And then I stirred the solution for about 60 seconds until it was all dissolved. There is still a slight orange cloudish color, that if you want to get rid of, all you have to do is filter it through a coffee filter into a funnel and then just put it in another cup. So just take the funnel, put the coffee filter in it, and then pour your mixture in it and just let it trickle through, and it'll clear out if you have excess particles, which I don't. I have a little bit on the cup, but there's none actually inside the solution. And then it'll give it a nice clear color, which will give you a nicer reaction. It'll make this a little funner. And we will come back to this. We are not done with solution A. This is just the first step. So again, it's 2,000 milligrams of vitamin C and then 60 milliliters of distilled water. Now for solution B, which I have right here, we need our cornstarch, which you need about 0.4 grams of cornstarch. But if you don't have a scale, you don't have to be exact with this. What I did was I took a 1/4 teaspoon and I scooped it out and I put it in this cup. And then I added 350 milliliters of the distilled water. And then I stirred it up and then I let it get all nice and mixed. I don't have any cornstarch particles in there. It's real homogeneous. So what we need to then look at is this is cloudy. So you have a little bit of a cloudy mixture. And again, you're not going to be able to get rid of the entire cloud. But if you wanted to, you could heat this up, try and break down the particles a little bit more, have them dissolve in the water a little bit better, and then you'll have a clear solution. So what we actually want to do is now we want to take solution A, which was our vitamin C, mix it up just a little bit because it's been sitting here. And then we want to take our entire bottle. I have 30 milliliters here of iodine tincture. And what we're going to do is open it up and we're going to dump it in here. And now, as we dump this in here, the solution is going to turn dark. And then hopefully, if we do this right, it should clear up. Because what's happening is that when the iodine, I2, it's converted to iodine, I minus, when it reacts with the vitamin C. And now this is actually a reduction reaction. See how that happened very, very quickly. It went red and then it almost immediately turned clear. So again, this is a reduction reaction. And if you remember the mnemonic, Leo says "gur," you can tell if you lose an electron, you're oxidized. If you gain an electron, you're reduced. And you can tell what kind of reaction that you're going to have. So now that we have that, so in solution A, what we have is vitamin C and then I- ions, because again, the iodine converted to iodide when it reacted with the vitamin C. Now, because I'm doing this at home, this is a home experiment, don't have several beakers to use. So what I'm going to do is I'm just going to take a bowl, and then I am going to take solution B, which is approximately 0.4 grams of cornstarch, and I'm going to dump it into the bowl. This is just because the only reason I'm dumping it into the bowl is because I needed a bigger vessel, and I didn't want to continually overflow cups. So we don't want to do that. And then in this cup, I have 150 milliliters of hydrogen peroxide, which is something I forgot to mention that we needed at the beginning of this. So H2O2, hydrogen peroxide. So I'm going to take this hydrogen peroxide, and then I am going to mix it into solution B. I'm going to take a spoon. I'm just going to stir this up a little bit. So we have 350 milliliters of water and then 150 milliliters of hydrogen peroxide in here. So we have 500 milliliters of solution B. So now that I have solution A, I want to have equal parts. So I need to top this off. So I do have a container here, and I'm going to dump it in here just so I can measure, because I want to have 500 milliliters of each solution. So I'm going to dump this in here, and I'm going to top it off with the distilled water. Okay. So I have 1,000 milliliters altogether. Okay, now what I'm going to do is I'm going to take my vase. We're going to pretend this is a nice beaker, and I am going to pour my solutions in there to see what kind of reaction you get. Now, before we start, there are a couple things that could impact the reaction time. So the temperature of the water will obviously impact the reaction rate. I'm spilling a little bit. Our concentration of vitamin C, and stir that up. Concentration of vitamin C, and then H2O2, hydrogen peroxide, and the mixture will impact the reaction rate time. So what is happening in here is the hydrogen peroxide, H2O2, and vitamin C, they actually compete at converting the I- back to I2. And this happens really rapidly, back and forth, back and forth, back and forth. And we cannot see it happening as rapidly as it is. But what will eventually happen is the excess hydrogen peroxide that we have in here will consume the vitamin C. So the vitamin C is our limiting reactant in this. And once the vitamin C is completely exhausted, completely consumed, I2 will begin to accumulate in here. And then once the I2 accumulates enough, it will form a complex with the I- to create a triiodide complex. That triiodide complex will complex with starch, and we should have a nice blue color in here. And we'll give this a little bit longer and see if we can get this to work. So I know you can't see very well. It did change a little color. So I don't think that this experiment is going to work the way that it's supposed to, which is fine. That happens. Not all experiments work the way they are. And there are several different reasons for that. What I am suspecting happened is that we do not have a high enough molar concentration of iodine in here. So the iodine actually became the limiting reactant, and we couldn't consume all of the vitamin C to create the triiodide complex with the I2 complexing with the I-. So that is what I'm going to say happened here is we had a good experiment, but we do not have enough molar concentration of iodine tinature, so we cannot complete the experiment as planned. And again, that's okay. So thank you very much.